Okay, so welcome again one more time to the modeling a Steel I Girder using the Wizard. This training class uses the file that I sent you when we started all these series, and is this one, Introduction to OpenBridge Designer. On the link that I'm going to send you after the session, it includes also a link to that training class. It's all bookmarked, and we're going to be covering this one. Right, chapter 4. I'm going to try to follow more or less step by step on what it does. So we're going to be able to create that steel bridge. Right, so with further ado, so let's start using the wizard. All right, so I have OpenBridge Designer open. I'm just going to create a new file, and that is our OpenBridge Designer OBTX file. And with that, we contain the projects, then two different workflows. It could be the Bing workflow and the standalone workflow. Up to you how you're going to access that. Right. So we can do a standalone, for example, since I usually do. I mean, that's a personal preference of mine, is that with the standalone workflow, I can try many different alternatives without even creating the 3D model in OpenBridge. Right? Maybe you got an old leap file. That's also a question that comes along. I have an old leap file that I need to use, and I don't have a 3D model yet, or I don't need to create a 3D model because it was an old project, but I still need to open leap. Well, then use the standalone workflow in OpenBridge Designer, and then you can access LeapBridge Steel, LeapBridge Concrete, or RMBridge in the standalone workflow. So you have an old RCP file, ConeSpan file, a GeoMath file. Well, you remember GeoMath. Yeah, it's here, right? So you can open it here and play your bridge. What you cannot do, though, is from a leap file, create a OBM model. No, this is you. If you do this, you remain strictly analytical. On the other hand, if you work with the BIM workflow, right, and you create a project there, your analytics are not accessible because in the Bing workflow, we just restrict the use of any changes that you want to make into the model. It needs to be done here, right? So basically, I will use personally when my project is more or less set up. I know what bridge type I want. I don't want to change that much on the geometry, so I'm just going to secure it mostly for reports, plans, production, and analytics could be done. But knowing that this is the bridge that is going here, I can just go back and forth. I mean, even I would say, and discard some of the changes that I'm doing on the analytical part because they said it's not pertaining. I need to just remodel the whole thing. So as I said, it's up to you which one you're going to use. And it all depends on the status of your project, right? So, and then I have also my colleague, friend, Steve Willoughby, answering your questions on the chat window. So feel free. Mike is posting some questions. So, well, Steve, go ahead. Anyway, so let's go. Let's go ahead. So I'm going to follow the manual, as I said, and go open OpenBridge Modeler here. What about this opening in my other screen? And here we go. Right. So you need to access the files that I give you. Again, most importantly, pick the workspace, the setup, the configuration that many different organizations will provide to you. Right. You see me here that I'm working in some of them already. Some of them they are customizing. They are not fully published yet. Florida is one published. Michigan is published. Right. So, but then let's use the Imperial standard. This is the one that comes by default. And I'm going to open in the Bentley training directory. That's where our data set opens up. Introduction to OpenBridge Modeler, Imperial. There is also metric units there. And I'm going to go to module 4. And the manual calls to open the Steel Bridge Wizard, BGN file. That's an empty file, right? That's an empty file. It will just open that up. Okay, so, oh, it's opening, it's opening. All right, so I open. And the file is blank, right? As we did on previous projects, right? We need to reference the pertaining information, meaning the geometry, the ground that I'm using. So all that information needs to be attached as a reference file. If you have an existing alignment, an existing profile that we have in this training class provided, right? So I will just go and use reference files to attach my geometry, right here, tools attach, and I will need to attach in that same folder the geometry. I will use constant word, my geometry and my terrain for that. So let's open it. Let's do a feed view right here. So and a feed view right here. So that is in 3D isometric view. The file is 3D by default, but this is just like that. I can also attach the corridor. Let's do that as well. So I will do tools attach, and then I will attach the corridor model, Route 97 that is here. So I know the limits of my bridge. You know that, you should be familiar with this setting because this is the one that we use also to place in previous session, our precast girder bridge with the wizard knot. So this is where my bridge is going to be, right? So now in previous sessions as well, we have done our bridge step by step using the different tools in the ribbon here. But then here I will attach the terrain as well. Here, let me do this. So select the terrain right here. And said, oh, there is no active bridge, I'm sorry. Yes, I need to create the wizard first. So I go with the wizard. Let's do this. Okay, here we go. So it will open the wizard, right? And I want to do a steel girder bridge. I can adjust some materials that these materials are coming from your material library under utilities. Now you can have a geometry or not. The software will create automatically an alignment at these specific coordinates that you can set up even with a curve. However, we have a full project here, so you can pick the alignment from the list. And if you don't know the name, don't worry about it. You can also pick from the screen, accept it, right? And then scroll down. You see how the stations are changing? Well, you can do that. Maybe snap to it, eyeball it, or actually, if we follow strictly the manual, type the station is there, right? So you can do that as well. So let me move to the screen better. That's it. Now, templates. What template you need to use, right? You can use the templates that are, again, into the utilities tab here, into the libraries. You can use that, right? So you can use any of these, right? But with the wizard, all these dimensions that are already stored as default in the template library, you cannot change it. So you will play and just put it shot. What we recommend, if you have a very specific deck and you still want to use the wizard, right? Make the units that you want or the dimensions that you want your default. So the utilities, well, let me show you. Let me start here. Like for example, I know that in my utilities library here on decks, right? Let's see, this is going to be a 50-foot deck. So if I go here, let's say I'm going to use this, the default values are 20. So this is actually 20 and 20 is a 40 feet deck. And if I use that with the wizard, well, I cannot change the dimensions. It will use the default of 40 feet, but I want to use 50, right? But I still want to use the wizard. So what we recommend, if you want to use the wizard and then maybe you're going to try different alternatives, different type of beam layouts, different beam sizes, all with, in my case here that I'm presenting to you, a 50 feet deck, I will strongly suggest you then you can do is say, okay, copy that, right? Make this, or you can even rename, say, okay, this is going to be 40 feet. Sorry about that. It's going to show on the video. That's a 40 feet deck. So then saying that, so then I can go and say, okay, this is going to be a 22 here, save it. And on the right side is going to be also a minus 22 with the same slopes. So now I will have a 40 feet deck. And it's a different thickness. You can also change it and so on and so forth. So I will have, right? So I can just create my own template, very quick, very specific to the project here. On the other hand, that's one. If you are changing this a lot, right? So, but then here on the wizard tool, we also incorporate, if I go back again to the wizard, so I will switch one more time to my steel girder, select the alignment, and just type the new station that I specifically need, 67.5, right? So look, now from the library, I can access my new 44. Expand the list right here. See, now I have my, oh, no, that the 44, right? Or I can just create a custom deck really quick, right? That's what the wizard is doing in the manual here. So it's 44, right? A new thickness, either or, right? So maybe you have a custom super elevation that you want to build into the wizard. Yeah, maybe you can do that. All right. So enough about the deck. Right here, spans. So you know, I have 80 feet, two spans at 100, and then last one at 7. So I will have what? 4 spans. The manual calls for, no, calls for 2, add 2 spans at 110. I can write it like that, or I can also do it like that. Oh, sorry, 110. That's it. Right? So you can do that. Skew angles, if you need to do this skew angles. Beam spacing, right? Let's do 5 beams, 9.5, for example. That's what it means. Again, following the manual. Right? And then you can do a beam template. So a built-up shape, a roll shape that is already in the library, or more generic, just create a constant built-up shape that you can later change on when we're doing the beam layouts. But you can do that, right? So we follow the manual strictly to, it says that it's 42 on depth, thickness is 0.5, width is 14, right? And thickness is 1 inch, right? Then also from my library as well, right? I can just access what abutments I want to use right here. Right, it's going to be a pile cap abutment. I'm going to use that configuration. Right? So select that. And the pier template as well. I can just modify that and use strictly that comes from the template itself. You know that later we can also modify all of this. And the same with the barriers. Right? The manual calls for Virginia type of barriers. So we can also do that. Right? So it's calling for the BP3 on the left and also for the BP3 on the right side, right? So all good. Stations, Steel I Girder, let's go for it. And then it will start building the bridge all in one shot. And then you got your steel bridge all done, right? So that's all there is. Now, what we have, right? So, well, you have all the elements. A good way to explore what we have generated is use the Explorer, right? So then here on the Explorer option, as it opens up, you can dock it too. You can just dock it right. I'm doing right here, right? You can review in your bridge model what you have generated. So certainly you have generated a bridge units, right? And that is a bridge. And these are all the elements that if you have to do it manually, right, you need to develop. The decks, you have developed the decks, the beam layout, right? So remember the beams at 9.5 feet separation, right? And the specific beam that you have been developed to as well, right? So all these options have been generated. If you have used all of these, you will generate that. We did it with the wizard, would make it our life way much simpler right there, right? So, and that's what we have so far. So let me clear up the selection set. So now, what else you can do with this, right? So let me clear on the Explorer the selection. I still have selected the elements. So right here, I have the beam groups already selected here. Okay. In layouts, the decks, and all that. All right, so it's clear. Now, what else can we do with this? Right? So let's add some cross frames. That is on page 80 on the training guide, right? So now let's do it right like that, right here. Okay, now cross frames. So now the cross frames are already part of the library, right? So you have to have this in your library. So if I go utilities, cross frames right here, we will use in this training manual some of the cross frames by name, right? X frame, X frame 1, X frame 2. So where all of these are coming from, right? And here, right? So these are all the templates that we have, right? So when we call, for example, in the training guide, you will see on page 81 that we're saying, oh, place X frame 1. Well, that's the one that we're placing, right? It's already fully defined, right? Or what you can do if not to create your own, right? You can just copy that one, right? So it creates a copy. You can change the name here. Say, okay, this is the X from testing, right? And then you can just modify anything you need, right? The top struts, the bottom struts, the diagonals, what profile you want to use, and all of that options. So you can just change anything you need here, right? So the configuration of each element, of course, and also the connection plates. And these connection plates are by name, you see, CP top right, CP top bottom. You can activate or deactivate them. Just deactivate the top right, update the drawing, so I don't have a connection plate anymore, right? So, or I can activate it as well, and then I will have it too, right? So now where these connection plates, CP top right, left, center, come from, right? So now you know the cross frames, right? All these different configurations. that we may have, right? B frames, X frames, and all of that. But also the connection plates are part of the library. And the CP top right left are these ones that we are using for the crossframes. Also, we use stiffeners, and the stiffeners come from here, right? So on the stiffener library, we're going to be using that, for example, 6.5 inch. So these are the definitions with all the detail that you need. Later, too, we can define a library of field splices, right? And just change your configuration too. And also we have, since I'm here on the topic, shear studs too, right? So all these massive shear studs that you can do, you can also activate it, right? 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 So you can also activate it too. Okay, so here we have all of this. So saying that, right, now let's come back and place some cross frames. So page 81, I will go home here, right? And I will say, let's place some so let's do that on the cross frames and just let's see what we can do. Page 81, we come back to place some cross frames. Now here we got to use our standard menu here, and I will go and select the beam group in which I'm going to place the cross frames. So it could be the beams here in the top view, the beams in 3D, whichever it's easier for you to select, right? So select the beam group, left click to accept it, right? And enlarge this. Okay, so we're going to place it on each one of the base, right? So we start, of course, with the first one. And even though you can add it one by one, it's way much easier to use the wizard again, right? Many options to place that. So we can place the cross frames at, I want it, for example, at 10 locations, or maybe I want it on a specific spacing, right? From the beginning of the bridge all the way to the end of the bridge, maybe even with a certain offset. I want the orientation to be up station. And I want, remember the name, X frame 1, X frame 2, right? So I can use X frame 1. Remember the stiffener names? Here they are. If I have more stiffeners on my library, of course, I will have a more selected list. And then I can just click on generate, right? And it will generate a list ready to be placed. Don't hit anything yet. Again, we just place the first set of cross frames right only on that bay. That one, the other one is not ready yet. But also we haven't finished here, right? Even though I have it on the first bay, I also wanted to place some cross frames, maybe of different kind, at very specific locations, so I can use one by one. So for example, I want one specific one at the beam start, right? So at the beam start, I want to do it at down station, and I want to place now a diaphragm right here with the same stiffeners, right? And just do that. So I will just go and generate it, but I don't want it right at the beam. I want it 1 foot from the beam start. So do that, one. Now, I want also another one, as it shows on the manual, page 82, step 8, at the beam end, but I don't want it right at the beam. I want it a foot before the beam end. And I want the same diaphragm, right? And I also want one at 0 location, but right at the pier, right at the support line 2, right? And the same diaphragm, and generate. right? Don't click that many times because you will have repeated locations, right? So that is all good. Just for the first bay. See, the other bays are not quite ready yet, but I would rather copy that to the rest of them. Now I have it. See? And then I can just go and save it, and it will start the process of placing the cross frames all along the process here. Right? It's doing that, and it will just generate that. Now we can answer some questions in the meantime. I think it's still doing this. Lateral bracing has answered that. Bob, you have your cross frames right there. Right? Remember the one that we place right at the support? Well, it's right here. And it's only a diaphragm, so it's only just a beam across. Right? So now you can add more options, of course, right? So the manual asks for on page 84 to add shear studs. Yes, you can add it, but it will be so many elements that I would say I'd rather do it these at the end, because as it creates that many elements, sometimes it's really hard, not hard, but I would say it takes a little time to update every single element that is placed. So I would rather do that at the very end of the process too. It doesn't pay that much difference when you do it, but I will just wait a little bit. I'll wait to the end of the process. If I'm still going to be changing, I will rather do it at the end. Right? All right. Now, my colleague Steve is answering these. And it's worth to mention here live is for what happened, right? I place X frame 1 as a cross frame right here, right? So what happened if at one point they decided that, well, that cross frame that I just placed needs to be modified. It uses a different profile, a different thickness on the plates, for example. So, well, two options. The hardest one is delete and place it again. But the other option is to go to the library and under that name that I use, X-Frame1, update the dimensions, right? And when I close the library, the software will know that X-Frame1 in the library that is being used here was updated and it's the same name, and it will just update the bridge automatically. Okay, so that is the question that Steve answered on the chat window. Now, what else we can do? We have less than half an hour and we're done. Fill splices, right? As I mentioned before, in my utility library here, I got a library of fill splices here, right? So you can define the position of the bolts, the size, the diameters on that, the top flange and the bottom flange too. And so you can create that, and you can create your own library too. You can copy and create a new fill splice library, right? So you can do that. Well, if we follow the manual too, on page 86, it says that, well, don't mess up with the standards. Just copy one and call it class fill splice, right? So you can change the bolt diameter to a complete different one, right? Standard one, 0.087. And on the web, the number of bolts on the row could be 7 here. Just see, the graphic doesn't update; it just tells you the dimension, right? And in 2 columns, in 3 columns, up to you, right? So we can do 7 bolts in 2 columns, for example, right? Or 7 bolts in 3 columns. But again, it doesn't update, and it's going to show you the 3 columns, right? So it's going to show you that, and then there's some warnings as well, right? So we can save that new dimension or new fill splice, right? And then here I can go into home and say place fill splices and select the bin group one more time. And that's the bin group, set it. And then here specify where do I want it, right? So for example here, I want to specify, oh, I want that, the one that I just created, right? I'm going to place it along, measuring from support lines, not from the beginning of the beam, the end of the beam, so by ratio. So I just want it by distance from the support line, right? And I'm going to place it based on support line 2. So let's see if this makes sense. From here, from the support line 2, right, this pier, I want to place one fill splice at 37 feet, 35 feet to the left, right, or up station, right, or back of the support line, and 35 feet ahead of the support line. That's what these minus and pluses is. So we do that, and then we just add it right here. So it automatically computes that, right? So you put more on the list. So for example, I can delete it all, and they said, oh, I want one at 35, let's see, one at 60. So it will automatically add the last line too. So, right, so let's do just as the manual says, add it, right? And then for the other beams too, I can just copy that definition to the rest of them and just hit save. As we hit save, then the field splice placement process will start. You will get one somewhere around here, right? Here you go. So let's see, where was that added? As I said, it was 35 feet. So it has to be somewhere here. Let's see. Right here. 35. My dimensions are what that right here. So these are the fill splices that were added into the process. Right? And the filler plates are added automatically too. Okay, so you don't need to specify that, as you can see. So the filler plates are added automatically. So that will finish the modeling of that steel girder. Now, icing on the cake, I would say. So then here, I can just go to analysis, to utilities. Well, analysis and reporting too, you know, that we can just, because we assign materials to it, right? So we can do the quantities report and then automatically get, even for detailed cross frames, the quantities of the bridge. Right? And we can just have all these dimensions, even by the cross frames, all detailed. That's what I asked, like all the struts and the diagonals, all of that. So 19 pages of quantities here, all being computed. Yeah, and if you add a unit price, well, you also got how much this bridge is going to cost. Right? We showed you before the deck elevations and all that options, but then also here, if I can go utilities, I can go and say, okay, now my 3D model is good. All right, now let's see if I can just send it to Leap. See if this can be calculated or not. Right? The model has to be complete. You don't, of course, you cannot have mistakes into the model, so LibRich still can take it. So maybe, hope I didn't make any mistakes, so it will be transferred. That. Right? So LibRich is opening, and then you will have the LibRich model there. Right? So then you can proceed with the actual design and analysis of the bridge. Right? So it'll open on my other screen. So let me bring it up. So that's the leap that it opens. Right? LibRich Steel. Here, it opens with the roadway tool. So let me take the roadway out and then do a fit view on the 3D model there. So that is my 3D model. With everything placed there. Cross frames. So then I can proceed fully to, depending even on the state, the code that I want to use, right? I can proceed to do the analysis here. So all these dimensions, everything is transferred. So I can just go and do the analysis. If I don't, maybe sometimes I need to retouch, I can add some stiffeners there or extra stuff. So we can use three different methods like girder, find it or retouch. This is part of the leap steel class, and just do one just in case, just to do a quick line girder analysis. Right, and then just proceed with the design in general. Right, so that is now, as you can see, the beam, the real beam approach that we're using, mixing a physical model in OBM with an analytical model on lip bridge steel. Right? If something doesn't work, let's see, the stresses that you get are not desirable, right? So then basically what you need to do is, I would recommend you to go back to the model, change the dimensions, so adjust the dimensions and push it through again to leap, so you can see the options there, right? So all these moments are here for all the initial stages, uh, initial and final. And also you can do not only the analysis part, let me open that, so, but also you can do the design part of it, right? It runs design checks, right? Depending on the amount of beams or the checks that you do, it will do a design check. I'm just doing basically one beam here. That's the only one that I design, right? And then just do a full design check in great detail, checking basically every article of the code right there. So in all the points, with all the low combinations and what elements you want to check. I access all of them, for example, and then I just submit. And well, that is every article of the LRFD 9 code in this case that I was using was checked to generate a very detailed report of all these options right there. You know, not only on section properties, but factored forces, everything that you can imagine is being generated. So far are 55 pages of that particular report. Get results and if it passed or not. Right? There is also, again, could be a very extensive report, but there is also summary reports, cross-frame reports. There are questions on the chat window of the cross-frames, and well, we can check. Oh, I didn't do a line girder, so there is no cross-frame reports, but then we can do all of this. Right? So, and these are more analytical reports here. All that information, right, that you generate, right, all the analytical information, it's all saved within OpenBridge Designer. You see, this is the wizard, this is the DGN file that I'm using, but I also save that lib file. That lib file, it's inside the OBDX file, right? So if you really need to get somebody that lib file just completely disconnected from the project, yes, you can do it. You can just export the group and send it so they can open it in another application. If not, everything is within the OBDX file here. Kind of separate, but also together at the same time. All right? And well, we are at the 45 minutes. So, and that's basically, that's it. That is your bridge. You know that you can do, you know, typical sections, you can do some drawing reporting and all of that. That will be a topic for another session. But other than that, this is how you use the wizard with cross-frame, field splices, and well, maybe we can just also place the shear studs. It will take a little time to do it because it's a lot of elements following the straight geometry, right? And doing that, I can specify as well if I follow the manual here. How do I want to do it? Right, and spacing and all of that. So I can add a certain spacing here and do the shear studs too if we follow, right, what it goes into page 84 here. So I can say start location at half a foot after the beam, right? So end location, it's at the end of the beam, for example, right? And I want a spacing of 0.75 feet. This is the type of shear stud that I want to use. I want, for example, 3 studs in a row, space, let's say 6 inches on that, right? So that will be on just one beam. And that same configuration, I want to copy that to the rest of them. And then just save. So now it's going to create a ton of elements right there, right? Well, guys, that's all there is. So until this waits, you can see the entire model. And other than that, that's all I have. So if you have any questions, microphones are open. So feel free to voice your question here. If not, I think Steve has done a great job answering all of these questions on the chat window. So anything else? We'll see. Again, this will take a little time to process, right? As you can see, it's still cranking up. Oh, yeah. I mean, that's a quick question, a good question, Amir, here. What about a non-standard beam? Well, actually, that's what we use. We use a non-standard beam. That's a built-up shape that we use, right? So you can define the top flange, the bottom flange, and the web. But also, you can define as well a beam with hunches, right? So you can also do that and configure the beam, right, as it's varying. So you can still also do that. A question about the civil conference. Is the cover? Well, the agenda is already online, right? It's going to be a lot of presentations on open roads. On bridge, for example, we're going to be covering the new development of item types as well. So that's on bridge, and then also some plans productions capabilities too. So the agenda is out there, so you can just subscribe to specific sessions. It's not going to be the whole day. It's a staggered sessions, so it doesn't take your entire day to attend the sessions. Okay, how the program addresses flare spacing on beams. Well, yes. You're right. Here in this example, you have seen how we handle parallel beams, right? Because again, we use the wizard. On the next Ask Alex presentation, we're going to do more step by step, so that you address it, for example, on the beam layout, right? On the beam layout, it doesn't need to be parallel beams. It could be flare beams for widenings, for example, you're doing that. So you can just really customize the geometry in which the beams are placed. And also, as a mere question, the geometry of the hunch beams, for example, on steel that I use a lot. And what about curve beam? The same. Remember, we follow the alignment. So if your alignment is on curve, we just follow the alignment. And if you got a curve, well, the beam will be curved. Also, we got the option to actually assign alignments to each beam. So if you, for example, in steel, sometimes they use that they want to use rounded radiuses, right? So yeah, you can also do it. You can also assign a specific alignment, right? A specific geometry, I would say, to specific beams, and the beams follow that. Right? Can it generate drawing plans automatically? Yes, we can do. Remember, this is a 3D model, so we can do any cut, I would say, typical section, cross section that you want to generate. And that will be a topic of another session on how to do plans production with many different tools, especially the microstation tools too. Yes. Steve already answered. Yes, we can perform code checks for shear studs and crossframes. Right. So now you know, right, that even this is a small bridge to generate shear studs. It doesn't crash. It's still cranking up. You know, we have 200 feet of beams. 5 beams, and we're generating the studs, 3 studs per row, every 0.75 of a feet. So it's a lot of solid elements being calculated and being placed. That's what I'm saying. I usually leave to the very end because if you really want to model that, it will take time to place. Okay, so just keep in mind that. And I know maybe we need to expedite this process, but again, there are many, many elements being generated at this time. All automatic, all being calculated. And woof, it's done. But not bad, right? For, I would say, thousands of elements being generated right here, as you can see. So all the shear studs has been generated. So they are placed right here, and then also you got it all the way here. Right, so that's what I'm saying. Place it the shear stud at the very end. You can show it, and then also you can do quantities with it, okay? So it's a full complete bridge right there. Right, and then again, I think it was somebody's question here. What about when there's no parallel? You can modify that right here. So actually, this is the beam layout that we do in 2D. So you can select this option here, right? And say, okay, let me modify the beam layout. You can just edit that beam layout and specify these options too. Right? So it will be using these tools. So again, you see it's the issue with the shear studs that also placed, right? So these lines specify the location of the shear studs. So I just select the beam layout line right here. All right, and when you edit the beam layout, this is where you can specify here. See, all these beams are parallel now, 9.5, 9.5 at the beginning and end. So you say, no, 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 I want to flare one of the beams. So you can say like the end of that particular beam, it's 11 feet, for example. So it's going from 9 to 11. And if you hit save, it will update the entire bridge. So it will update all the shear studs, right? So it will take also a little time, but this is what you can do. And also you need to assign a specific geometry. Well, you got the option here that you modify that you have a pull down menu here of all the new alignments that you can generate. So you can make your beam to follow also a specific geometry. And that will be also be covered in our topic with advanced beam layouts capabilities here that you can do. Okay, so there is a question here for deck replacement project. Do you recommend going with beam workflow or a standalone workflow? Existing substructure and existing beams need to be checked for new deck. Again, it's up to you as a preference. I like to keep consistency on the design. I would like to use the beam workflow, right? Because then, you know, I had established the connection between physical and analytical. I don't need to worry about it because I know that my model rules, basically, right? So that is the recommendation. Now, existing substructure and existing beams need to be checked for the new deck. You're right. Yeah, you need to model them and check it. So not only that, the existing substructures, depending on the rules of the state or the DOT, sometimes if you touch a new bridge, you got to retrofit the entire thing. So you need to make it up to code, not just the widening part, but the entire bridge. So this could be quite challenging. Right? So, I mean, so we can have them in a BOM report. Yeah, bill of materials report. Yeah, I mean, if you need to model the entire thing. If you want to include the existing substructure and existing beams and all of that, yes, you have to model it and include it on the report. It will be a matter of playing with the existing features or the feature definitions to label some of the elements existing or proposed, right? That is something as well that we can cover that. So 5 minutes going, and I think that we answered most of the questions. So again, or one more time, guys, thank you so much for attending this session. So, and other than that, that's all I have. And as I said, we covered these today.